voice here. You can hear in the back. No, you cannot hear, so I'm gonna speak from. You can hear from the back, but some of you cannot. Then maybe I speak from there. Okay. So yes, this is the topic I was working on for my summer research. So hopefully it's gonna bring a bit of different perspective into the field of agriculture. The story I want to talk about here today is about open-mindedness in agriculture. And here's one story. First thing to know about, I have to be honest with myself, is that I'm very stubborn when touching to the subject of chemical pesticides. Given the fact that I know that it's a major part of integrated pest management. And when I signed up for my summer research program, it was a different project. It was looking at life cycle for a pathogen, and which I just want to improve my molecular biology skill. But the project was expected to take longer time, so it would change to fungicide resistant. And my head was furious when I hear about this term, because I didn't want to work on fungicide. And what happened is my supervisors, they was all very kind, supportive to my study, my research. And I came back to my home country for 2 weeks, and I think, why didn't I, keep my mind open about this area? And I came back with an open mind and start to learn more about it. And first thing I learned from my supervisor is that in reality, it's difficult to convince farmers not to use chemical, and especially in the case of monoculture. And so I'm gonna get blank a bit, but the reason is because to change from conventional farming to sustainable farming, it takes time. From less use of chemical to no use of chemical, it takes time, and it doesn't happen in a blink of an eye, a hand. So, and the second thing I learned is the fungicides I study here, strawberries, is come from the fact that humans try to mimic, which is in the top left corner of the slide, which is coming from the fact that humans try to mimic natural mechanism. And the source of strawberry is coming from a mushroom called Strawberries tenacious. And what it does is, when it's happening in the forest, it releases a chemical that prevents attack from other fungi that challenge its nutrition resources. What it does is that you can see on the top right that the yellow E-flow transfer is the electron transfer in the mitochondria of the fungus. And this mushroom, it releases a chemical that blocks the electron transfer in the fungus, and then it blocks the cytochrome, which I hope can you see the mouse? So this is cytochrome B-zine. It blocks the cytochrome B-zines, and then it stops the electron transfer, it stops respiration and energy production of the fungus, leading to the death of the fungus. And a similar mechanism was replicated in the chemical production of the fungicides. So it's a very complicated slide there, but hope you don't get bored with that. And the pathogen I'm studying is Pseudocercospora physiensis. It's a long name. So what it is it's a causal agent for Black Sigatoka. It leaves disease spot in banana. And in Australia, there was 9 incursions of Black Sigatoka, and the last time was in 2001. And when it happened, even when it was early detected, it cost about 17 Australian million for the eradication program, which is about 5% of the total industry value of banana. And so what I study here is the fungicide resistance. And when the resistance happens is that normally strawberry bind to this middle of the cytochrome B gene, and when there's a mutation in the position 143, then there's a change from glycine to alanine, and then the fungicide can no longer bind to this part of the fungus, which is in the middle of the big change you see here on the top right. And
So I was screening about more than 50 samples from neighboring countries of Australia, and I used PCR, which is polymerase chain reaction, and resistant digest mechanisms method to detect the resistance. And I used a DNA control sample isolated from Costa Rica, and the result here you see this is an example of the result. That actually this is what I found before I sent another slide. Yesterday I found a new result that actually there's resistance happening in neighboring country of Australia, in Malaysia, in PNG, in Solomon Island and Torres Island. So this means that even if farmers apply strawberry in the outbreak of this disease, it won't be effective. And also, it does not just only cost money, it's going to bring out unnecessary environmental impact. And that also indicates that there's a need to develop new kind of fungicides to prevent the disease spread when it's happened. So I started with a bit of story about open-mindedness with agriculture. I was hoping that with the result I got on Wednesday, that there was no resistance. I hope to bring back that open-mindedness a bit. But with the result I got from yesterday, it seems like we still have to stick with a bit of fungicide at the moment, and to wait until there's more affordable, sustainable agricultural practice. And that's it. So I hope this brings a little something.